We have discussed about the construction of bituminous layers, construction of concrete layers, so on. Now let us look at the safety aspects during construction, which is a very important aspect during construction. There are requirements for this safety during construction. Number one, safe passage of road users with minimum delay. That is one of the important requirement. Just because we are constructing, we should not delay the road users much. And construction activities and traffic control are two important aspects during construction, and there should be better coordination between the traffic control and the construction activities. Both are equally important. There should be progress in the construction and there should be a better traffic control and management. So this needs to be coordinated well. That is second requirement. And as we know, speed is highly related to the road safety and the accidents. So speed reduction in the construction sites is another important requirement. And suppose if the construction is in urban locations, we should always look for alternate routes for traffic management, traffic diversion, if there is a chance, if there is a opportunity, alternate. So we should look for alternate routes in urban locations. And then the important is there should be rapid progress in the construction activities so that the delay for the road users is reduced. But there should be safe, efficient, and progress of construction activities. Even the progress of construction activities should be safe and should be efficient. It's not that you are only targeting the progress. No, progress with safety is important requirement. There are guiding principle for the safety during construction. What are those? Number one, we need to warn the road user very clearly, well in advance, not suddenly telling there is a construction activity going on. No, we should warn the road user well in advance about the activity. And we need to provide safe and clear marking for guiding the road users. There should be enough markings and there should be a safe passage area for guiding the road users properly. So, and this guiding should be safe. That is what it means. So we should provide a safe and very clear guiding for the road users through furnitures, through road safety furnitures, through pavement markings, and so on. There should be the other principle is we should provide a safe and a clear buffer for the work zones, both lateral and longitudinal buffer zones. What is this buffer? I'll just show you a little later. So we need to provide the buffer zone. We need to clearly mark which is working zone, which is buffer zone. So that is another important principle. And there should be enough measures, adequate measures to control the driver behavior when he is passing through the construction site. So these are the guiding principles: warning the road user well in advance, providing safe and clear marking for guiding the road user in the construction zone, giving clearly marking the buffer and work zones in the construction zone. Adequate measures for controlling the driver behavior are some of the guiding principles. But again, there are some legal aspects need to be attended to, need to follow for the construction zone. We need to obtain the legal permission from the road authorities and local police, traffic authorities and local police. That is important. Contractor has to obtain the permission because he is awarded the contract. He cannot just like that go and stop the divert the traffic or uh, partially control the access to the traffic. So he has to take necessary permissions from the authorities concerned. That is one. Number two, this is very important. Yes, construction is also important. At the same time, any construction activity causes inconvenience to the road user, but there should be minimum inconvenience to the traffic. That is what it means. So the contractor has to take all necessary steps so that there is only minimum inconvenience to the traffic. And the third aspect is he should guide the drivers in clear and positive way. Overall, the traffic safety should be given the very high priority. Unfortunately, this is not so in our country, but slowly we are started giving importance for this for so many reasons and compulsions from the department, from the police, from the court, and so on. So now truly, I mean, safety is considered to be a priority in the construction. If you take the construction zone, there are four components in the traffic control zone. There are four components in the traffic control zone in the site, construction site. Number one, warning zone. Second, approach transition zone. Third, working zone. And fourth, terminal transition zone. And this is the figure showing the elements or components of traffic control zone. From here to here, this is considered as traffic control zone. And this traffic control zone consists of advance warning zone, approach transition zone, working zone, and terminal transition zone. And here what you are seeing, this is a two-lane carriageway, and this is the actual construction site where work is going on. And these are the barricades. These are the barricades. So the space between the actual construction spot and the barricade is called buffer zone or buffer area. And this buffer area is called lateral buffer zone. And this buffer area is called longitudinal buffer zone. So now let's look at the advanced warning zone. This zone. So what we do in the advanced warning zone? We warn the road users about the presence of hazard. What is the hazard here? The construction. And we even tell what is the distance to the hazard, 500 meters ahead, 300 meters ahead. So we indicate the road user about the distance to the hazard and also the presence of hazard through signages. And we also convey, advanced warning zone also convey the changes in the traffic lanes, number of traffic lanes, or reduction in the carriageway width. Also convey what is the speed limit to be followed, in the warning zone, in the construction area. And advanced warning zone, the extent of hazard is also conveyed, so like deep excavation, overhead clearance, and such restrictions are clearly uh, conveyed well in advance to the road user. So type of hazard is also conveyed here. Extent of hazard is to what length the hazard exists for 200 meters, 300 meters, for or half kilometer, for next 1 kilometer. This is the extent of hazard. The type of hazard is deep excavation, overhead clearance, and so on. Then comes, after the working zone, then comes approach transition zone. It's a crucial zone. There are several factors to be considered in deciding the length of the transition zone, approach transition zone. Number one is the turning radius of the longitudinal vehicle. You have seen here, this is the transition zone, approach transition zone, and this this length is decided based on what is the turning radius of the biggest vehicle using this road facilities. Let's say if this barricade is something like this, perpendicular, direct 90 degree, then vehicles cannot maneuver. So depending upon the turning radius of the vehicles used, the length of transition zone is decided. And drainage system in the construction area to be carefully considered while deciding the transition zone. So because we may be damaging the existing drainage system in the construction area, so that there are very chances of ineffective drainage. So we should take care of the drainage, and avoid ponding of water in the construction area. So this also plays an important role in deciding what is the length of the approach transition zone. Addition to that, dust that is likely to rise, likely to the quantity of dust or the effect of dust in that construction area also influences the transition length of transition zone. Barricades, signages, channelizers, markings are very essential in the transition zone. Night visibility to be achieved through using reflective sheets, reflective paints, and need to control the traffic through signals or by manual flogging in the transition zone, and need to demarcate clearly the waiting area in the transition zone. So then comes our working zone, actual working site. So this working zone consists of two components. One is the actual working space, and as said, the lateral and longitudinal buffer areas, buffer zones. So controlling the speed in this zone is very important. We need to use appropriate road furnitures, signages to control the speed. Need to effectively utilize the delineators and channelize the traffic is very important aspects. Channelizing and delineating the traffic are very essential aspects in the working zone, so that the work is not hindered, safety of the road users is given due importance. Then comes our terminal transition zone, the last zone. Compared to other zones, the warning zone, the approach transition zone, and the working zone, the length of this terminal transition zone is very less and need to be less so that the area is cleared um, and what is this distance is only to this distance is required to clear the work area and return to the normal traffic lanes, and generally this length is less. And what is the length of this terminal zone? It extends till we see a end restriction sign. So that means where this terminal transition zone ends, it ends where this signage is installed, end restriction of end signboard. So that you should know. So here comes the length of different traffic zones: warning zone, transition zone, working zone. And this length depends on what is the speed of the vehicle. What is the speed of the vehicle? The speed is 50 kilometer or less than that. The length of advanced warning zone is 100 meters. The length of approach transition zone is about 50 meters, and length of working zone varies depending upon the type of construction activity and its requirement. Let's say if the speed is more than 81 kilometer and up to 100 kilometers, the advanced warning zone varies from 300 to 500 meters. Approach transition zone varies from 100 to 200 meters. And of course, the working zone, length of working zone varies depending upon the type of activity and its requirement. So, the length of the zones depends on what is the speed of the average speed of the vehicles. We need to, as said, we need to use various traffic control devices to control, to guide, to warn the traffic in the construction zone, construction areas, construction sites. And these traffic control devices play an important role in warning the road users, informing the road users, guiding the road users, modifying the behavior of road users, and protecting the road user and also the vehicle, and provide safe working area, thus ensuring the safe passage of road user in the construction area. So this traffic control devices plays an important role. This figure shows the construction activity in the center, and this is a two-lane traffic, and see the signages, see the directions, right? So similarly, see the signages in the opposite direction. So you find all men at work, change in the direction, uh, preference, and then no overtaking, change in the direction, right? All with reflectors. Similarly, on the other direction, you can also see where these signages are placed 1 kilometer ahead. That means uh, work in progress 1 kilometer well in advance. The signage is placed. Similarly, the change in direction of the lane is placed 750 meters ahead, and preference warning indicator signages 500 meters in advance, and so on. Similarly, on the other uh, direction, you can also see end of the construction work here, signage. So this is uh, the work on a two-lane carriageway in the center. So here also you can see different signages, direction signs, end of construction, and reducing in number of lanes, warning about the construction site. So when strengthening of a two-lane carriageway is undertaken, shoulder adjacent to half of the carriageway can be used for diversion. When we take up any strengthening work of a two-lane carriageway, we can make use of the shoulder as a lane, diversion lane. And this shoulder should be suitably strengthened to cater to the diverted traffic, and uh, the strengthened pavement along with the strengthened shoulder is used as diversion here. So what treatment to be given for the shoulders when shoulders are used for diversion, and shoulders uh, sorry, the composition of the diversion lane, uh, is presented here when we take up the strengthening of the work for a two-lane carriageway. This is how the treatment for the shoulders. 150 thick granular base course with a thin layer for a width of 1.5 meters. And if this should be there for a 500 meters length, and the quality of the surface is to be maintained. The shoulders, this what is that presented here in this PPT here is, when we take up the work of strengthening of two-lane carriageway, shoulders can be used for the diversion lane, and they need to be strengthened. And they need to be strengthened using these pavement layers. 150 thick granular base course, something like wet mix macadam, a thin surface layer, maybe uh, uh, surface dressing, mixed seal surfacing, and they should be continuous for 500 meters. If the construction activity is longer than 500 meters, then we need to construct passing lanes of 20-meter length, paved width of 2.5 meter at every 0.5 kilometer intervals. So if the length of construction site is more than 500 meters, then we have to construct what is called passing lanes of 20-meter length with a paved width of 2.5 meter at every 0.5 kilometer interval. So this is the treatment to be given for the shoulders when we take up strengthening of two-lane carriageway. When we do the temporary diversions, there should be smooth horizontal and vertical profile. Just because it is a temporary diversion, we cannot have a, uh, a poor horizontal and vertical profile. And these diversions not to get overtopped by flood or drainage discharges, and should have adequate capacity to cater to the projected or existing traffic. And these diversion roads are to be dust free. There should be clear visibility both during day and night. Because it is temporary diversion, doesn't mean that visibility should be poor. No, there should be clear visibility both during day and night. There should be barricades to prevent the construction materials from falling on the diversion road. Proper barricade should be there. Barricading should be carried out. Temporary diversions are required when it is not possible to allow traffic on one part of the part of the carriageway, and the specifications, the guidelines for temporary diversions are here. Carriageway of 7.7 meters, shoulder of 2.5 meters, and this is the pavement composition. 200 mm compacted granular subbase, 225 mm of granular base, and a thin layer, uh, mix seal surfacing also, and other such layers. We need to follow some traffic management practices at the work sites. We can have different traffic control methods depending upon the speed of the vehicles, length of the work zone, length of transition zone, and the traffic volume. So depending upon the traffic volume, length of work zone and transition zone, and the speed limit, the type of traffic control methods are chosen to control the traffic in the work sites. Now let us take one such method, or here are the methods: give and take system, priority sign method, stop and go method, portable traffic signal method. When do we go for give and take system? When the maximum speed limit is 50 kmph, the length of work zone and transition zone is 50-meter maximum, and the traffic is only, two-way traffic is only 400 vehicles per hour, with 20 commercial, maximum 20 commercial vehicles per hour. When this kind of traffic situation exists, and if this is the length of work zone and transition zone, and this is the maximum speed limit, then we can go for give and take system. And we can go for priority sign method if the maximum speed is 160 kmph, and length of work zone and transition zone is 80 kmph, and the vehicles, maximum number of vehicles in the two direction is 850 vehicles per hour. So we need to adopt, we should select this kind of portable traffic signal method of traffic control when the maximum speed limit is 60 kmph, and length of work zone plus transition zone is maximum of 300 meters, and traffic is, there is no limit for the traffic. So means to say, depending upon the traffic, depending upon the work zone and length of work zone and transition zone and the speed, the traffic control methods are chosen. And this figure shows the traffic control by give and take system. This is the traffic lane. This is another traffic lane. You can see the signages, men at work, signage indicating the reduction in the number of lanes. So there is a hazard markers, and there is a direction control sign. And this is the barricades, and this is the actual construction site. Similarly, the other direction. So we can adopt this give and take system when there is low volume of traffic, and there are less number of trucks and buses. The total two-way traffic flow is less than 400 vehicles per hour, and the trucks are less than 20 numbers per hour, and speed limit is 50 kmph or less. The length of works from the start of the lead in taper to the end of the exit. Taper is not more than 50 meters. Drivers approaching from either direction can see both ends of the site. So when this is there, when drivers approaching on the both directions can see both ends of the site, I think this system we can adopt. provided if the traffic is less and speed is less. So this is another method, traffic control by priority signs. You can see the signages here, and you can see the priority sign here. Priority is given for the traffic coming from this direction because the obstruction, the barricade is in this lane. So this is construction site and this is the barricade, and traffic is moving in this lane and this lane is free. So the preference is given for this lane. Preference is given for this lane. So when the two-way traffic is less than 850 vehicles per hour, this method is, this choice can be adopted, and the tapering should be not more than 80 meters. Drivers approaching from either side can see to the side from the point of 60 meter from their transition zone to a point of 60 meter beyond their terminal zone. If the speed is less than 50 kmph per hour. In case of higher speed roads, the appropriate clear visibility distances are 70 meters on 60 km per hour roads, and this is not applicable if the speed is more than 60 kmph. This is priority must be given to the either the unobstructed vehicle or vehicles going up a steep gradient. So priority is given for the unobstructed vehicle where the obstruction is not there in a particular lane. That lane traffic is given the priority, or the vehicles going on a steep gradient are given the priority. This is detour. This is the construction area, and this is the route, diverted route. So the signages you can see. This is other method. So this here the traffic is rerouted to an alternate road so that the traffic totally avoids the work zone. When the traffic is diverted from the road under construction or improvement to an alternate traffic road, construction works proceed very rapidly. So this will improve the construction efficiency, quality, and ensure safety for the workers from passing vehicles. So this method can be applied, this detour can be applied for all categories of the vehicles, or applied only for some category of vehicles depending upon the site situation. So this detouring imposes additional capacity, and the low demands on the alternate road may cause concession. Safety consideration on the detour route should be considered duly, particularly if the detour route goes through vulnerable areas like residential areas, school zones, etc. And detour should be carefully evaluated to ensure whether these routes can safely accommodate the passage of the type of vehicle and the traffic volume before implementing. Use different traffic control devices to control the traffic in the construction site. Prohibitory signs for signs for controlling the traffic, and mandatory signs and warning signs. Use different types of traffic cones, cylinders, drums, and barricades for controlling the traffic. In this figure, you can see the cones, different size cones. Here, this height is 750 mm, this height is 500 mm. You can see delineators here, delineators without the reflectors, delineators with circular reflector, delineators with rectangular reflectors, and this is a drum delineator. And these are the different types of barricades. Type 1 barricade, this is type 2 barricade, and this is type 3 barricade, and this is another type of barricade. Normally this type of barricade you have seen in the Bengaluru metro construction. So what are the recommended dimensions for different components of these barricades? The components of the barricades, like the width, the length of rail, the width of strip, height of barricade, type of the frame for the barricade, flexibility and retro reflectivity of the barricades varies with respect to different types of barricades. So for type 1, width of uh, type 1, type 2, type 3, the width of rail varies from 200 mm to 300 mm. For type 4, it's about 2000 mm. The length of rail varies from 2 to 2.5 meter for type 1 barricade. For type 2, it is 1 meter to 1.2 meter. And for type 3 barricade, the length of rail is 1 meter minimum and maximum varies. And for type 4, it is 2550 mm. The width of strip is 150 mm for all types of the barricades. The height of barricade varies from 1 to 1.5 meter for type 1, 1 meter for type 2, 1.5 for type 3, and 2.5 meter for type 4 barricade. The type of frame is heavy A-frame for type 1, light A-frame for type 2. It is fixed demountable frame for type 3 and also for type 4. So coming to the flexibility, type 1, it is essentially a movable. Type 2, it is a portable, and type 3, it is a permanent, and type 4, it is permanent. The retro reflectivity sheeting to be used for barricades, it is class B sheeting for all types of barricades. So type 1, type 2 barricades are used when traffic is redirected. These type 1, type 2 barricades can be used interchangeably and are more useful for repair work that is initiated on emergency basis. The support for this type 1 and type 2 barricade should be of A-frame configuration or hinged or otherwise flattened at the top to permit convenient folding and stacking for transportation of this barricade. Since these barricades are susceptible to the overturning in wind, their stability can be improved through ballasting. Type 3 barricades are permanent type and can be made up of wood or metal. These barricades are erected at a point of closure when road section is closed to traffic in the construction site, and these barricades may extend completely across the roadway and its shoulder or from curb to curb. So where provision must be made for the access of construction and supervision vehicles, type 3 barricades must be provided with a gate or a movable section that can be opened or closed as and when required. Signs such as road closed, detour arrows should be erected on the fixed barricade. Type 3 barricades are again used when there is long duration works are carried out. In urban areas, they serve the purpose of screening and the separation of traffic from the work area, but should not be expected to provide much protection. Therefore, Type 4 barricade should be installed at such locations which should prevent all kinds of entry exit by the road users, construction workers to workplace, and also those works which are not intended to be seen by public, so that it distract the driving attention. So type 4 barricades not to be used on roads, highways having high traffic volume or speed, since they do not provide much impact when impacted. So these are direction indicator barricades. Barricades is a hazard marker, clear direction is a warning. This direction indicator barricade may be used in tapers, transitions, and other areas where specific directional guidance to the drivers or necessary is necessary. If used, direction indicator barricades should be used in series to direct the driver through the transition and into the intended travel lane. So there are various lighting devices, variable message signs here. These are the warning lights, truck mounted attenuators, flashing warning beacons, rotating amber light. So lighting should be provided in the construction sites, and these lighting devices are used to supplement the channelization. Maximum spacing for the warning lights should be identical to those of channelizing device spacing requirements. Four types of lighting devices are commonly used in work zones: floodlights, flashing warning beacons, warning lights, and steady burn electric lamps. These lighting devices may be used to supplement retro-reflectorized signs, barricades, and channelizing devices. During normal daytime maintenance operations, the functions of flashing warning beacons may be provided by high-intensity rotating, flashing, oscillating lights on a maintenance vehicle. Then comes the floodlights. Utility, maintenance, or construction activities on highways are frequently conducted during nighttime periods when traffic volumes are lower. So large construction projects are sometimes operated on a double shift basis, requiring night work. So desired illumination levels vary depending upon the nature of task involved. So an average horizontal luminance of 50 lux can be adequate for general construction activity. Task requiring high level of precision and extreme care may require an average horizontal luminance of 216 lux. So type A low intensity flashing warning lights are used to warn the road user during night time that they are approaching or proceeding in a potentially isolated hazardous area. Type A warning lights may be mounted on a channelizing devices. Type B high intensity flashing warning lights are used to warn the road user both during daylight and night time that they are approaching a potentially hazardous area. Type C steady burn warning lights and type D 360 degrees steady burn warning lights may be used during night time to delineate the edge of the traveled way and channelize the traffic. When used to delineate a curve, type C and type D 360-degree warning lights should only be used on the devices provided on the outside of the curve and not on the inside of the curve, as these may hit by the passing traffic. So this is a temporary road for culvert construction. Figure shows this is a culvert activity. So this is the traffic control management devices for a culvert construction on a two-lane road. So you can see the cat eyes, raised pavement markers, the information boards, and the end of restriction sign here. That means beyond this point, it is normal zone. Till we see this sign, this is traffic control zone, advance warning zone, transition zone. This is a diversion area. So this diversion, traffic diversion, the traffic on one or both directions is routed onto a temporary road constructed around the work zone and reconnected to the permanent infrastructure of the designated route. This provides a positive separation between traffic and the work zone. Diversion can carry one-way or two-way traffic. This is especially useful in construction of bridges and culverts, as seen in the figure. So this figure uh, shows the lane narrowing due to the work at the center. This is the work in the center. So because of this work in the center, the lane's width is decreased on the either side. So all the signages you can see here. So lane restrictions. This strategy entitles reducing the width of one or more travel lanes. This strategy should be adopted when maintaining traffic with less than desirable travel lane width is preferable to other alternatives. This can raise safety concerns, and therefore reduced speeds are very critical when you go for this method. This picture shows using the shoulder. This is the shoulder, this is the carriageway, and shoulder is made use of here for the diversion. So shoulder as a travel lane. So outside or inside median should be used as a temporary traffic lane. This may require constructing or upgrading the shoulder pavement structure to adequately support the expected traffic loads. And this strategy uses existing roadway width to compensate for the capacity lost by closing a permanent travel lane, and can be adopted on facilities such as divided multi-lane, undivided multi-lane, and two-lane roads. The existence, the proximity, and nature of roadside features, example bridge piers, need to be considered in assessing this strategy. So this is median. This figure shows the median crossover in a two-lane dual highway construction. Median. So this is the median, and you can see the median crossover here. Traffic coming from this direction is turning, coming to this side of the median. So this median crossover strategy is most suitable on expressways and divided carriage highways, where two-way traffic on a normally divided highway facility is allowed. Number of steps are necessary to implement this strategy, which includes reducing the number of lanes in both directions of travel, that is closing the lanes, routing the traffic in one direction across the median to the opposite carriageway, maintaining two-way traffic on one carriageway while opposite carriageway is closed. So then comes full road closures. If the property executed leads to safe, if properly executed, leads to the safe work zones and reduction in work time such that full closure is actually better than considering the delay that we cause in the construction. So the full closures can be effective and successful on the road strategies with low, medium and high traffic. If full road closure is chosen, whether it is short term or long term, the need for detours must be weighed against the safety, the operational benefits of the full road closure. So the other one is intermittent closures. With this strategy, the traffic in one or both directions are stopped for relatively short period to allow for the construction. This work zone strategy alone is generally not adequate for entire construction project intermediate closures. It is more suitable for specific operations such as setting bridge beams. Intermittent closure should be used for short duration, maybe less than 30 minutes outside the peak hours, peak periods. So the next one is lane closures. When one or more traffic lanes or any adjacent shoulders are close to traffic on one lane of a multi-lane highway. So when lane closures are used for long-term projects, use of barriers should be considered, which can increase the cost of implementation. This strategy can be adopted for a short period, maybe few hours, if barriers are not provided. So in this table, you can see the different types of strategy: alternate one-way operations, detours, diversions, full road closures, intermediate closures, lane restrictions, median crossovers, use of shoulder as a travel lane, night constructions. What are the advantages and disadvantages, and a summary of all these strategy? So you can look at this table. Let's say, for example, full road closures. What is the disadvantage? Potentially significant traffic impacts. What is the advantage? Generally involves speedy construction, separates traffic from constructions. So what is this? Let's take median crossovers. What is its median crossover? Maintains two-way traffic on one carriageway of a normally divided highway. What is the advantage of this strategy? Separates traffic from construction. Right of way is not required. So what is the disadvantage of median crossovers? Relatively costly. Interchanges need special attention. So depending what are the different strategies available for traffic management in the construction sites, their salient features, their advantages, their limitations are mentioned in this table. I think this table is visible. So thank you. So we are closing down discussion on safety during construction.